Good morning, everyone. First of all, I would like to thank the organizing committee for the opportunity to present our work today. My name is Feyyaz Muhulligil, and I am from Bahçeşehir Cyprus University, Nicosia, Northern Cyprus. Today, I will present our study entitled In Vitro Evaluation of the Selective Cytotoxicity Potential of Erodium pelargoniflorum boas and head against human cancer cell lines. Cancer represents a major global public health, societal, and economical challenge in the 21st century, accounting for nearly 1 in 6 deaths worldwide, and approximately 1 in 4 deaths attributed to non-communicable diseases. Among women, breast cancer is the most commonly diagnosed malignancy and the leading cause of the cancer-associated mortality, followed by lung and colorectal cancers in terms of both incidence and mortality. In contrast, lung cancer is the most prevalent cancer among men and the leading cause of cancer-related deaths, followed by the prostate and colorectal cancer with respect to incidence and liver and colorectal cancers with respect to mortality. Prostate cancer in particular represents a significant global health concern and is among the most prevalent malignancies affecting men worldwide. Kidney cancer also constitutes a substantial global health burden. In 2022, an estimated 434,000 new cases and 155,000 deaths were reported worldwide. In addition, cancers of the brain and central nervous system account for more than 322,000 newly diagnosed cases globally. And the genus Erodium layer comprises 122 accepted species distributed across Europe, Asia, North Africa, North and South America, and Australia. In Turkey, the genus is represented by 26 species and is commonly known by the vernacular name Dönbaba. Previous phytochemical investigation of Erodium pelargoniflorum have revealed the presence of various alkaloids and phenolic acids and its aerial parts as determined by the planar chromatographic analysis. In addition, extract obtained from the aerial parts exhibited antispasmodic activity on isolated reticulum and uterine tissues. Furthermore, Erodium pelargoniflorum has been reported to possess significant cytotoxic activity as well as inhibitory effect against alpha-glucosidase, alpha-amylase, antiurease, acetylcholinesterase, and butyrylcholinesterase enzymes. And Erodium pelargoniflorum has antimicrobial activity. Moreover, several dodecyl alpha L-rhamnopirazonyl beta-D-fucoperazide derivatives has been isolated and characterized from the glandular trichome exudates of the Pelargonium floriflorum. Erodium pelargoniflorum. The present study aimed to evaluate the in vitro anticancer activity of the Erodium pelargoniflorum against a panel of human cancer cell lines, including lung, glioblastoma, prostate, breast carcinoma cell lines, while HEK293 cells were employed as a non-cancerous cell model to assess selectivity. Erodium pelargoniflorum was collected from Karaman Ermenek and identified by Ömer Çeçen. A washer specimen was deposited in the herbarium of Selçuk University. Aerial parts and roots of the plant dried in the shade were ground in the powder in the plant mill. The dried and powdered materials were sequentially macerated at root temperature within dichloromethane, ethyl acetate, and methanol. After each extraction with a solvent, the plant material was dried to remove the solvent completely and then subjected to extraction with the next solvent. Each extraction process, lasting 24 hours with the same solvent, was repeated 3 times. The extracts were separately concentrated in a rotary evaporator under reduced pressure to dryness at 40 Celsius degree. And the human cell lines were cultured in the high glucose DMAM. These media were supplemented for 10% heat inactivated fetal bovine serum, 2 micromolar L-glutamine, and standard antibiotic antimycotic cocktail. Cultivation was maintained under standard conditions at 37 Celsius degree in a humidified atmosphere of 5% carbon dioxide. Cellular proliferation and survival were evaluated using MTT method. Optical densities were recorded at 514 nanometers. On this slide, you can see the cell lines used in this study and the biological systems they represent. This figure illustrates our proposed mechanism for the selective cytotoxicity activity of the extract. On the left, HEK293 cells, which represent non-cancerous human cells, showed no significant cytotoxic response. On the right, MCF7 breast cancer cells exhibit significant sensitivity to extract. This interaction could subsequently activate apoptotic signaling pathways leading program cells. When it comes to results, none of the test extract exhibited significant cytotoxicity toward the non-cancerous HEK293 cell line, suggesting a degree of selectivity toward cancer cells. In contrast, the positive control colchicine demonstrated marked cytotoxic activity against these cell lines. Among all tested samples, the dichloromethan extract obtained from the roots of the Erodium pelargoniflorum exhibited the strongest cytotoxic activity against the cancer cell lines evaluated. The extract showed pronounced inhibitory effects against MCF7, PC3, A549, U87Mg cells with IC values 22, 29, 40 and 47 microgram per milliliter respectively. Similarly, among the aerial parts extract, the dichloromethan extract displayed the highest cytotoxic activity, yielded 27 microgram per milliliter against MCF7 cell lines. Nevertheless, colchicine exhibited substantially greater cytotoxic potency than all tested extracts across the investigated cancer cell lines. The dichloromethan extract of the root of the Erodium pelargoniflorum was the most active extract against breast and prostate cancer cell lines. This slide integrates the 3 major findings obtained from our cytotoxicity study of Erodium pelargoniflorum extracts. First, regarding the selectivity profile, none of the tested extracts exhibited significant cytotoxic activity against HEK293 cells. These observations suggest that the extracts do not induce indiscriminate cellular damage and may preferentially target malignant cells, indicating a favorable selectivity index. Second, when comparing different plant organs, root extracts consistently demonstrated greater cytotoxic activity than the aerial parts. And third, analysis of the extraction solvents revealed a clear polarity-dependent trend. Cytotoxic potency decreased as solvent polarity increased, following the order dichloromethane, ethyl acetate, and methanol. This pattern suggests that the principal bioactive compounds possess relatively nonpolar chemical characteristics. Previous studies have reported cytotoxic activities in several Erodium species, in particular demonstrated that the ethanolic extract of the aerial parts of the Erodium pelargoniflorum exhibited moderate cytotoxic activity against MCF7 breast cancer cells. Taken together, in the conclusion, these findings indicate that the selective cytotoxic consistence of the Erodium pelargoniflorum are predominantly localized in the roots and are enriched with the less polar phytochemical fractions. Therefore, future phytochemical investigations should focus primarily on nonpolar root extract to isolate and characterize the compounds responsible for the observed anticancer activity. Thank you for your attention.